This is going to be a very, very brief overview on what are the common memory problems on let's say, well, JVM or ARC-based runtimes. So, for example, when you run Kotlin on backend or in Android, this is a very, very big subject. So I'm going to just give a very quick overview. And there's like a GitHub repository with slightly more text. And I hope that you can make questions and issues there for stuff that you think is or could be useful there for you to read. Brief, a few words about like myself, just to give some credentials. So I have worked on JVM based languages, I think, since 2005 or so. I have done work on multi-terabyte heaps and high performance computing. And we once had this funny half-a-year bug with the garbage first, garbage collector that kept crashing the whole JVM. And with my colleague, we've found the issue and submitted a fix for it. So I have like one commit in OpenJDK under my name, but that wasn't like a totally only my thing. But there's like a probably the people, especially on the Android side, might feel that the high performance computing might not have that much to do with your normal work, and it can partially be true, but there's also like the thing that in more resource constrained environments, so be the resources then CPU or memory, you want to make sure that you don't use too much resources, so that you don't get, say, bad feedback from your customers that your application isn't responsive or things like that. We're going to go here quickly through so that like a few common cases, how we can ascertain that this might be the case in our program, and what we can do about it, and then a brief overview on also the tools that I will probably mention during the presentation. And all those tools with short descriptions are linked in the GitHub repository README. So first we'll define a few terms, just so that there's a understanding of what we are talking. So one thing is a reachable object. So it means some object in your program code that the program code can still use at some future point. So for example, if you have a method that creates an object at this beginning of the method and never use it afterwards, after we have gone through this start of the method, it's no longer reachable, and it might get collected by garbage collection. Garbage collection is automated way to handle one resource, namely memory. We have also some other resources that we can kind of handle through garbage collection. For example, network connections or file descriptors, but those are like incidental mechanisms built on top of the garbage collection functionalities, and not something that garbage collection does as such. Then we have a working set, which means some amount of memory that we need to do some like the largest amount of memory we'll need to do something. So this might be, for example, during a request, we construct on backend a big bitmap in memory. So probably the working set of this request is the amount of memory the bitmap uses and some other stuff that we need to have in memory to be able to construct the actual bitmap. And this is the concept of working set is it's very simple, but it's important to keep in mind so that it kind of like puts the lower limit into how slim on memory side we can go, because if we need all these things to be able to calculate or do something, then we need that's like the minimum working set here. And then there's the allocation rate, which is how much a program allocates per some time unit. So creates new objects, no matter are those objects something that the program will keep using for longer time or shorter time. It's just like the amount of objects created. And there's like two basic failure modes when talking about memory problems. There's either you run out of memory, or you spend too much time doing garbage collection and not enough time doing the actual work that the user likes, for example, drawing screens or writing responses. And we're going to go quickly through both of these, like a few ways to make sure that we are, when we're having problem, that the problem is this, and then what to do about them. And these all, in a way, simple, except that all the tools and the garbage collectors, they have their own intricacies, which make things harder. So we have the running out of memory thing. So usually there's two things here that can cause this. So we have too big of a working set. This is rarely a case in say piece of software that follow this kind of like a request response cycle, but for software that does some kind of, for example, batch processing, there might be that some of the things that it's doing just take too much memory compared to what is available. And the other one is that we are leaking memory. So even though garbage collection is supposed to handle the memory for us, we can still have situation where garbage collection sees the objects being reachable. So for example, you have some global variable or thread local variable. Maybe in thread local variables you have some map that points to another map that points to another map, and that's keeping a big chunk of objects still reachable. So as long as the program code can reach the objects, the garbage collection cannot release them, and we have a memory leak. So what we can do for these cases is, one thing is to figure out that, okay, start with the ascertaining that, hey, we are actually running out of memory because there's like a, especially on OpenJDK, might be also on ARC, cases where you get out of memory errors for cases where you still have enough of the so-called heap, so the memory available for Kotlin code available. But after that, if we see that, okay, we are running out of memory, one thing to do and make sure is that is the case is take a heap dump. So this can be done using either JMac command line tool or Eclipse memory analyzer or Android profiler, or we can do that also programmatically. And there we can then, based on this heap dump, we can check what are the objects that are actually taking the most of the memory. So if we were to release these objects, and are there something that we would want to keep in memory? So if the objects are something that we would actually want to keep in memory, then we have the case of big working set. And if the objects are something that we thought we weren't keeping in the memory, we're leaking memory. So depending on the situation, if we have the case of too large working set, we might solve it by adding more memory. This probably doesn't work if you're running on Android. You cannot just say to the users that, hey, can you get a bigger phone? So in that case, and in some more of the high performance computing cases, you might want to look into how to slim the data in memory. So this means that using a simpler presentation, using for example, all kinds of primitive values instead of say list of ints, you use int array for the same data. But basically, the solutions are add more memory, or use less memory, or find the leak. And depending on your situation, you might want to choose one or more of those. Then there's the other case where we might not be as such having like running out of memory, but we are using too much time in garbage collection. So instead of running the program code, we are running garbage collection. We are running garbage collection too often. So in Android, this because almost all garbage collectors commonly used have some parts of the garbage collection run where they do a so-called stop the world pause. So it's a situation where none of the program code runs and only the garbage collection runs. So if the garbage collection runs for 50 milliseconds, that's already like with 60 FPS, that's 3 dropped frames. If it runs for 100 milliseconds, what is it? 6 dropped frames. So this will soon be noticeable, and it will also be noticeable to your use of your service when the response times goes from a few milliseconds to say hundreds of milliseconds. The way to then figure out what's happening here is, again, one is to use a garbage collection login. I have a brief settings on how to do that in the repository link. So there we want to see that, okay, why are we running the garbage collection? And are we able to free the memory there. If we are able to free the memory, then the case is that we probably just have a high allocation rate. But if it's like that, we start with the 1 gigabyte free, then only 900 megabytes, then 500 megabytes freed, we are probably also leaking memory. So in that case, we want to do the similar thing as in the earlier case. So take a heap dump and figure out where are we leaking. And in the cases that we are actually just allocating too much, in those cases, it pays to use the profilers. So the Android profiler is able to profile the allocations and see in your code allocate. And same can be done with the Java flight recorder, also mentioned in the documents, and Java mission control. So there you can find that, okay, here we are creating a lot of objects. And then what can be done is either figure a way to not create so many objects, or add more memory so that we are running the garbage collection less often. You might see that, notice that in all these cases, there's always the solution of adding more memory or trying to fix the code. And trying to fix the code is often harder, but might be still worthwhile. And it's at least an interesting engineering challenge. So as mentioned, like these are more or less the ways to solve the problem of too much time. Then there's the slide on the tools mentioned. So there's with every OpenJDK, there comes a set of command line tools called, two of the most important ones are JMap and JCommand, which can be used to do ad hoc heap dumping and allocation profiling. But you can also, especially like in some environments, it can be very hard to just go and run these commands. So you can programmatically trigger heap dumps, which can help you to find out are you maybe leaking memory. And one thing that you should, at least on the server side, always enable is the garbage collection logs, which allow you to actually pinpoint many of these problems without needing to take the heap dumps when you learn to spot the signs of those. But that's it. Very, very brief look into two common cases of memory problems on JVM and what to do with them. So the message here is that the problems and solutions are nominally simple, but you'll need to do some work to get to know the tools available. Or you can just also try to do things blindly if you're in a hurry, but that won't help in more complex cases. That's it. So for the questions, I think those are probably best handled, like if you have some more specific questions, maybe through the repository, and I can try to help there.